Hello, everyone. I'm Mike Garuccio. I'm a principal technologist at Expedient. And today we're talking about optimizing the Elastic Stack for observability and fleet. So just to kind of set the stage here a little bit, tell you a little bit about Expedient. We're a cloud and managed service provider, and we've been offering services built on top of Elastic to our customers for logging since 2019. And really in 2021, this year, we began exploring Elastic heavily as a monitoring solution. And it's been great for us. It has a ton of great features, and we've really gotten a lot of value out of it. But there are one or two downsides here. The big one is that our typical monitoring customer is actually less than about 50 virtual machines, which isn't necessarily the target for Elastic Observability. And we were a very, very early adopter of Fleet. And so we have a bunch of experience with sort of the pitfalls of those small to medium environments when using Fleet. And the first one, really at that very, very early point, was our experience crashing a cluster when we got a little bit too excited about it. So Fleet basically fit our use case perfectly in terms of the ability to deploy agents out to all of our customers and really get configurations out in the wild. So as soon as it was released, I got pretty excited about it and deployed it onto one of our existing lab clusters. And without knowing too much about it, I went ahead and used our traditional index lifecycle management policies and turned on all the collection options and very, very quickly ended up crashing the cluster in about a week under extremely severe CPU throttling. So the first thing we realized is that we needed to change those lifecycle policies. They were really designed around optimizing for storage space, which absolutely makes sense when your primary workload is logging. And so we were doing rollovers, every day so that we were never keeping data more than about 24 hours outside of when we intended to keep that data. And that makes a lot of sense when you're dealing with, single indexes or a couple of logging indexes, because even if you're keeping it for 30, 60, 90 days, you're only dealing with, a few hundred indexes at most. That configuration, though, when we turned on Fleet, definitely does not work. Fleet intends for you to have your data very separated into different indexes so that you can do, unique lifecycle management around it, unique management around the way that data is actually ingested, which makes a lot of sense for big environments. But when you're talking about small ones, we very, very rapidly go beyond the recommended shard count of 20 per gigabyte of Elastic memory allocated. So the first big change and the by far most impactful one here for us was to realize that we needed to optimize around something different, in this case, shard count instead of data usage, and moving from a daily rollover to a monthly one. So that means that even though, we're committed to our customers that we're going to keep their data for a month, in some cases, we'll actually keep it for almost 2 months because we're only rolling over once a month. And that increases our storage usage, but has a massive performance impact in terms of reducing that shard count and lightening the CPU load. So the way that impact ends up looking is we basically have to 2x our storage usage because we have to build things assuming that, one day of the month, we're going to have twice the data that we intend to. But at the same time as you're increasing that storage usage by 2x, you're reducing the number of shards by 30x. Because again, you're only rolling over once a month instead of every day. So that kind of moves the bottleneck. So we don't get a 30x cost reduction, but we do get about a 3x reduction in costs, just based on the size of instances that we need to deploy. So this was really huge for us in terms of the ability to continue delivering services to our customers in a way that makes sense and isn't going to drive up our costs too high for us to be competitive. So that was kind of the primary big lesson that we learned, is be very, very careful about lifecycle policies and really think deeply about what you're optimizing for, and don't just copy and paste what you're using for your existing logging workloads into this new metrics and observability world. We did learn a number of other important lessons. Number one is to really carefully monitor your deployment. So it's important to go ahead and make sure that you're monitoring your shard count and alert when it gets near that 20 shards per gigabyte ratio. And that there are some additional challenges for, so that cluster stats, indices.shards.total metric that you see on the right here that you're really watching for isn't mapped by default. So you do need to go into your index template settings and make sure that you're explicitly telling Elastic to map that when it comes in. Once it does, though, it's pretty easy to go ahead and create an index threshold alert on the cluster and effectively just set it to, the condition to be 20 times whatever the memory amount for your cluster is. So in this case, it's a 32 gigabyte cluster. So we're looking for anytime we have more than 640 shards in the cluster, it generates an alert, and we can go ahead and respond to that and figure out what's happening, whether it's someone turned on additional metrics ingest or whatever it is, and get that back under that recommended level, which is really very important for maintaining a functional cluster. Also important to alert on whether the cluster is experiencing kind of excessive CPU throttling. So at least for us, we're an Elastic Cloud Enterprise customer. ECE makes it very easy to see when you're going over memory or disk space. It doesn't really present the CPU metrics as obviously. So you do need to go in and create some custom alerts for those. Thankfully, 7.14 does make that a little bit easier, so it's definitely worth looking at. But that's just kind of the other piece that we really needed to monitor. As a final note, though, on kind of that monitoring, in addition to the CPU and shard counts that you're looking at, you do also want to keep an eye on storage usage and really revisit ILM policies on very large clusters. So, we were optimizing around kind of that 50 VM instance, but we do have customers that are far larger. And in those cases, it actually makes sense to retune those ILM policies to be, biweekly or even weekly rollover to keep that storage space down. So again, it's even though the initial change for us was really to daily rollover, the important thing that we realized was that we need to pay more attention to where we're bottlenecking and make sure that we're optimizing correctly, even if that may be different for different workloads and use cases. The other thing that we learned is that namespaces are kind of problematic, and you should really avoid them where you can. Every time you add an additional namespace to a policy or in a policy, you're basically 2xing the shard count for the data that you're pulling in. And that's fine on big environments. It's not really going to be impactful. It's unlikely you'll even notice it. But for small clusters, that can be the difference between something that works great and something that crashes. So to kind of get around that and figure out, different solutions there, the first thing we realize is that in most cases, a lot of enterprise IT environments are already going to have naming conventions that really accomplish what namespaces are intended to, separating out things like dev and production environments. Frequently, you'll actually see names like, dev SQL 01, which gives you a lot of information that you probably want to separate information out on. So it tells you both that it's a development server and that it's a SQL server. So you can create dashboards that just look for the word dev in a server name. And you can do things like create exclusions in your alerts for, not monitoring memory usage on a SQL server because you expect that it's always going to use everything. If you're a more advanced user, it may be worth looking at ingest pipelines to do the same thing. This is primarily if you would typically have had, a large number of namespaces. It might be easier to look at ingest pipelines and enrich processors to pull in data from your CMDB or just from a static index, and then just attach additional fields that you can search on. That has its own CPU hits, so that's definitely something that you need to optimize around and experiment with, but it's a potential way of kind of figuring out better ways to work there. Other trick we learned is actually to use the new cold lifecycle tier. So basically in place of the warm one. The advantage here is that it basically cuts your shard count in half because no longer are you maintaining additional shards for the replica. That's now being tiered off to S3. And basically using this in place of the warm tier and being something that you roll over onto immediately means that you can still keep on performant hardware. So instead of using, different instance types or anything like that, you can go ahead and use the same nodes that you're using for your warm or hot tier, but only be using half of the shards. So you don't have a whole lot of performance impact there. You can't read from replicas anymore, but you're still able to hit your primary shards very easily and quickly. And at the same time, you still have your redundancy when needed. The biggest thing here is you do need to make sure that you have pretty reliable infrastructure, so you're not continuously losing the nodes that have your important data on them and then having to rehydrate from S3 very often. And you need to make sure that S3 is available and fairly performant so that when you do have infrastructure problems that require you to hit S3 for your replicas, you're not crippling your cluster. So this one's a little bit riskier. There are some more downsides to it than the other options we've talked about. But if you're really looking to optimize, it's something that you should definitely consider. One's definitely minor and is something that more came up with our kind of drive to really minimize costs. And it's actually something that we're not using in many cases, but it is an option that we keep when we need it. And it's to use an external fleet server. So right now, in Elastic Cloud, if you want to have fleet, you basically need to have an APM server as well. And that does add some overhead to your cluster. It's not a lot, but it is sometimes enough to move the needle on costs. And you can move that externally and that way no longer be required to maintain additional Elastic capacity just to maintain fleets if you're not using APM for other purposes. Again, that's definitely minor savings, may not be worthwhile, but if you're being very aggressive about optimization, it's something that's worth thinking about. And the final item that we really learned is that it's important to be careful when you're turning on integrations. So every time you turn on an integration, it's going to create a new data stream, new indexes. Usually it's going to create multiple, which is fine. It's something that you're definitely should do. You should definitely turn on integrations when needed to get more value out of the platform. But it's important to make sure that when you turn them on and then turn them off later, you're cleaning them up properly. So this is an issue where we saw problems early on and kind of had to make sure that our processes were correctly aligned around dealing with this. When you turn on an integration and then turn it off, it doesn't always deactivate properly. So you do want to make sure that you're not just turning off the index or the integration, but you're also cleaning up any index templates it created, deleting the existing indexes, and fully removing anything that's completely deactivated. The thing that kind of bit us here is that we had some customers who just went ahead and turned on a large number of integrations, decided they didn't actually need the data. It was causing too much performance hit to the cluster and turned them off. So we no longer had any data ingest coming from those, but what we didn't realize is that every day it was still, the index template was still there, index lifecycle policy was still there. So it was generating a new index every morning and no data was getting put into it. So in one case, we hit that alarm on a cluster having too many shards, went and investigated it, and about half of the indexes we saw were just completely empty. So we're spending CPU cycles to maintain those, Elastic to deal with those, and no one's getting any value out of them whatsoever. So, don't let this stop you from adding more functionality to Fleet, but just be aware that when you do add additional data collection, it is going to generate more indexes, more load on the cluster, and really be sure about what you're activating, and importantly, clean up things that you've deactivated. And that's everything for me. Thank you, everybody.